All right, so we are live right now. I hope I'm audible to all of you. All right, so welcome back. Welcome all of you to this amazing platform of Tutee Learning JEE. So today we're going to continue with our discussion on circles, right? So as we were discussing on circles and we have reached so far discussing on the concept of equations of tangent, right? And we saw how we can find out the equation of a tangent to a circle at a given point. Right. So if you recall the previous class results, we have so far found out that if we need to find out the tangent to a circle at a given point, and let us say that particular point is P, so the tangent to the circle at point P, let us say x1 comma y1, and at this particular point, if I want to find out the tangent at a given point, the equation of tangent was simply obtained as by doing this operator, that is t equals to 0, right? So if you recall the transformation, that is we just transform x square with xx1 and y square with yy1. Simply we transform x with x plus x1 by 2, and for y we transform it with y plus y1 by 2, right? So these are the important transformation that we need to remember in order to solve for the question of to find out the equation of a tangent to a circle at a given point P, which is having the coordinate x1 comma y1, right? So this is what we have discussed in our last class, right? And along with that also saw that how to write the equation of tangent in the slope format, and that was something as x equals to m times sorry, y minus k equals to m times x minus h plus or minus r square root of m square plus 1, right? This is what we have saw the how to write the slope form equation of tangent. Okay, slope form equation of tangent, right? So this is the slope form equation of tangent that we have saw in the last class, right? For any given circle which center is given as h comma k and the radius is r, right? So this is why we have finished till in our discussion of our last class, right? So with that I asked you to solve one homework problem, and I am pretty sure that you must have solved this problem. So if you try to solve this problem, you must be getting the answer something as I'm just letting you know the answer, okay? But and the remaining thing we have already discussed about the details of it, right? So if you want to find out the tangent to the circle at this particular point, you just need to do a transformation. So this will look something like x minus so x minus 2y is equals to 5. That is will be the tangent to the first circle, and this particular tangent touches the second circle as well. So you have to find out that particular point of contact. So if you consider this as the tangent for the second circle, and with that respect also you can find out the point of contact, right? So we have already discussed about this kind of question, right? Or maybe you can solve it by putting this value in this equation and solving for the quadratic equation in x or either in y, and then making the discriminant of that particular quadratic equation to be 0, since it is a tangent case, right? That is basically touching the circle at only one point, right? So with that, if you solve it, you will definitely get the answer something coming out as 3 comma 3 comma minus of 1, 3 comma minus of 1. That will be the answer to this particular problem. Okay, so if you try to solve it, you must be getting this particular answer. I am pretty sure about it, right? So this is where we have discussed till in our last class. Now today let us quickly discuss about another important concept that is basically called as the uh, length of length of tangent from a point of contact, from a point to the circle. Okay, so in order to discuss about the length of the tangent from a point to a circle, and let us call it to a circle, right? So let us first of all assume the equation of circle, and we have already seen that we definitely write the equation of circle in form of as, that is basically given as x square plus y square plus 2gx plus 2fy plus c equals to 0. That was what we have discussed as the general equation of the circle, right? This is the general equation of the circle. Now with this particular circle, we know certain few more quantities, that is basically the center of the circle is basically minus g comma minus f, And if I talk about the radius of this circle, this will be square root of g square plus f square minus of c, right? This is what we know about this general equation of circle, right? Now if I tell you that from a point which is lying outside this circle, let us call that particular point as P point, and if I want to draw a tangent to this particular circle from this P point, let us try to draw the circle like this, and from this P point, if I draw the tangent, that is basically given as x1 y1, and the tangent intersects the circle at point T. So if I want to draw the tangent like this, and this is a radius and this is a center capital C, and we know that the radius is always perpendicular to the tangent at the point of contact, right? So this is what we get. So we already know the radius, which is basically nothing but square root of g square plus f square minus of c, right? This is the radius of circle, and we can do find out this particular PC distance, right? So this is my PC distance, which I can easily find it out. So this PC distance, I can easily find it out, right? So if I find out this PC distance, what is easier is that is this particular triangle is a right angle triangle. This triangle PTC is a right angle triangle. So in this right angle triangle, I can apply the length of the perpendicular will be square root of. So by the Pythagoras theorem, this PT would be equals to square root of PC square minus TC square, right? We already know the distance PC and we already know the distance TC, that is the radius. So if I apply this form over here, so PC square will be x1 plus g whole square plus y1 plus plus f, right, plus f whole square minus of now g square plus f square minus c, like this. And then if I solve this particular ratio, or if I solve out this, carry out this algebra, I'm going to get the result something as, so this result would come out to be as just square root of x1 square plus y1 square plus 2 times of gx1 plus 2 times of fy1 plus of c. So this is going to be the value that is coming out. Now if you recall from the operator notation, so we have denoted the operator that is s equal to 0, right? Now if you recall from the last class, we have said that when I put the value of x1 y1 in this particular operator, we call that as s1, right? So this particular thing, or the length of the tangent, is equals to square root of s1. So this is the length of the tangent, or this PT distance, right? So length of the tangent is given as square root of s1, right? So first of all, if this point x1 y1 is outside it, so definitely my s should be greater than 0, because it is lying outside, otherwise it cannot be a tangent, and also which is very much relevant, because if s1 is negative, then I won't be having the length of the tangent to the circle, right? That will be a complex imaginary number, right? So with this, we have discussed about how to find out or write down the length of a tangent to a circle from a point outside the circle. Okay, so I hope this particular point is clear. Now, along with that, we were also discussing about that from a point lying outside the circle, we can draw two tangents, right? That is also called as a pair of tangents. So if I, from this point P, I can also draw another tangent like this to the circle. Let us call that point as R, right? And this is also going to be perpendicular with the radius, right? So now, instead of asking the length of the tangent, now because I know that both this PT and PR distance is going to be the same, this geometric distance is going to be the same because of the congruency of these two triangles, right? PTC is congruent to triangle PRC, right? So by that result, I have already seen this in our junior classes that PT distance, the length of the tangent from a point which is exterior or outside the circle, is going to be the same, right? But what if I ask you what will be the combined equation of the pair of tangent equation, the equation of the pair of straight line for this tangent to this given circle? Then how am I going to find it out? Let's try to quickly discuss on that, right? So before that, I want to ask you whether this is clear or not. Okay, please do let me know if this part is clear or not. Okay, is this clear? All right, so let us now progress towards understanding about the equation of the pair of tangent, right? So let us discuss about pair of tangent. right? So let us discuss about pair of tangent. So if I talk about the pair of tangent, as I was mentioning, so again, let us, for our simplicity, let us take a circle whose center is basically at 0, 0. Okay. For our simplicity, let us take a circle whose center is 0, 0, and let us take the radius as a. So I will get the equation of the circle to be coming out as x square plus y square is equals to a square, right? Now, if I take up any point exterior to the circle, that is basically my x1 comma y1, then from this exterior point to this circle I can draw two tangents, right, which is also called as a pair of tangent, right? Let us call this point as t, and similarly let us call this particular point as r, right? So so now what I have to write it down is basically that I have to write down the equation of this pt and the pr and get a combined equation of it, right? So for that, let us assume some point q alpha comma beta which is lying on this tangent pt, right? So let us consider q which is lying on pt. So if I want to write down the equation of pq, so if I want to write down the equation of pq, that would be given as y minus y1 is equals to slope is basically going to be beta minus y1 by alpha minus x1, right? That is going to be slope multiplied with x minus x1, right? That is what we will have as the equation of the line PQ. So if I write down it completely, this is going to come out something as y times of alpha minus x1 minus beta minus y1 times of x minus alpha y1 plus beta x1, that would be equal to 0. So this is going to be the equation of the tangent pt, right, such that this alpha comma beta is lying on this pt distance, right? Now, if I say that the Q point is lying on the tangent, and also please note that if I consider this Q point to be as T point, then the perpendicular distance from the center, that is 0, 0 to this line PQ, this is the PQ line, this is going to be the equal to the radius, right? So if I drop a perpendicular, or if I try to find out the distance CT, that is going to come out as the radius, right? Now, in order to find out CT distance, this is basically the perpendicular distance of this origin from onto this line PT. This is also the equation of line PT. So from here, if I just put it onto it, I will get the perpendicular distance formula. So that is beta x1 minus alpha y1 divided by, since my x and y are 0, so it is just these 2 points will vanish and only I will left out with this part, and then divided by square root of alpha minus x1 whole square plus beta minus y1 whole square, and take a mod of it, right? And that should be equals to a, right? So if I solve this algebra out, so if I try to solve this algebra out, I would definitely obtain the locus of alpha comma beta, and that would be the generalized equation of the tangent pt, right? That would give me the equation of tangent pt. So if I carry out this wholesome algebra by taking a square on both the side and then I simplify, I would definitely obtain some relation in alpha beta, and then if I change it for the slope from alpha to beta to x comma y, then I will get the relation to hold true, which is basically going to be x alpha x1, sorry, y x1 minus x y1. So I'm just replacing alpha and beta with y and x, right? That is what I'm doing. Whole square is equals to a square into x minus x1 whole square plus y minus y1 whole square, right? So this is what we will obtain. Rather, if I simplify by doing out this, carry out this algebra, so if you do this carry on this algebra, you will at a stage you will reach to a point something as x square plus y square minus a square, this particular part, into x1 square plus y1 square minus a square, and that will come out to be equals to x1 y1 minus a square, and this is whole square, right? This particular thing's whole square. So if you recall from the terminology, so this is basically the locus of this PQ, sorry, locus of the pair of tangent, right? Please note this is the locus of the pair of tangent, or locus of alpha comma beta, right? And because I mentioned that alpha comma beta can lie either on PT, can lie either on PR, can lie either on PR as well, right? So this is basically this particular point alpha comma beta is given with the condition that the perpendicular distance from the center to this tangent line is basically equal to the radius. So this can be lying on either of these two straight lines. So this locus of alpha comma beta will give me the combined equation combined equation of the pair of tangent to the circle, right? So therefore, if you recall from the terminology, that this is nothing but it is basically called as S, it is called as S1, and this is called as t square, right? This particular term is called as t, so it is t square. So therefore, what you can see is that the combined equation of the pair of straight line or the pair of tangent equation for any given conic section is always going to come out as ss1 is equals to t square. This is true for any conic section. Okay, so when I'm deriving this particular expression in circle, so I won't be doing the same derivation again in the case of hyperbola, ellipse, or parabola, right? If you are very curious to know about it, you can definitely do when we will discuss about chapter of parabola, but I'm not going to do that because I've already discussed about it. Maybe I will give you a homework, or maybe I will give you a hint on how you can get to that particular derivation for the specific conic section as well, right? But this hold true for any conic sections. Okay, so please take a note of this. This is called as a combined equation of the pair of straight line for the pair of tangent, right? I hope this is clear to all of you. I hope this is clear. Please do let me know if this part is clear or not, and so that we can keep on discussing with some of the important questions, and then we can move forward with our class discussion. Okay, I presume this is clear. So then we can move to solve one interesting problem, and this kinds of problems are very interesting, especially for mains and advanced both of exams, right? So it is very important to have ideas on how to solve these kinds of problems. Okay, so this is a very standard problem. So it is said that if the distance from the origin, so it is said that the distance from the origin of the center of the three circles. Okay, so here they have mentioned three circles whose center always lies on the x-axis, right, are drawn in GP. Okay, such that the distance from the origin to the center of the three circles are always in GP. Then you have to prove that. Okay, so this is a very interesting problem. You have to prove that that length of the tangent drawn to them from a point on the circle, this particular circle whose center is at origin, are also in GP. So this is a very interesting problem that you need to prove, right? Now you must be having this question that why do we need to solve proof that question, right? It is very important to solve this kinds of subjective question because it will help you to understand the basic regarding how we solve or prepare for board examination, right? So this kind of problems are useful in order to prepare for your board examination. However, in JEE Mains also this kind of problem can be asked such that they will ask you then how then the length of the tangent drawn to them at any point on the circle are in AP, GP, or HP. Maybe that can be made as an option, right? So it can give you in which of the following the which of the sequence is followed by the length of the tangents, right? Either it is AP, GP, HP, or combined AGP, right? That can be four options that can be given. So based on this kinds of questions, so it is very important to also practice some of the prove that question, right? Because some kind of modification can always be made to those questions to make it as an objective question. Okay, however, practicing prove that question or subjective question is going to be helpful, especially for your board exam preparation. Okay, so keeping in mind that you are also appearing for your board examination, or writing or practicing subjective question is definitely going to help you a lot. Okay, so please try to solve this problem and do let me know whether are you able to prove this or not, and then we can continue with our discussion. Okay, Ajay, hello. Ajay, bolo. Hello, Ajay. Okay, is this part clear? All right. So, Ajay, Bhaiya, I am a dropper and I have 90% of syllabus left. Is it still possible or should I leave left it at all? Okay. So, Ajay का question है कि I'm a dropper and 90% of the syllabus is left. Okay. See, Ajay, if you see, there are two attempts for JEE Mains, right? You are not, and I hope you are familiar with that, right? So maybe not in your first attempt you will be able to do well. However, your second attempt is going to be in April, okay? And you still have 3 months or more than 3 months left before your second attempt for JEE Mains, right? So I would definitely suggest you basically give a try, okay? It is not that you are just leaving it up, okay? So give a try. Maybe you can still be able to score a decent amount of score in your second attempt and maybe you can get into some good NIT, right? Or who knows, you can also clear the JEE advanced examination and maybe you can get into the IITs as well, right? So give a try. What my suggestion would be, please follow the lectures that I am taking on this particular platform. And if you have a lot of backlogs, what I would suggest is please contact me on this particular number. Okay. So the number is already given on the live chat as well. I'm still writing it on the screen. It is 83398 27528. Okay, so please contact me on this number and you can get enrolled to the online one-to-one batches, because what I feel at this point of time, you need online one-to-one batch. Okay, online one-to-one batch to clear your backlogs. Okay, so please enroll for this online one-to-one batch and clear your backlog. Okay, I want to come to your college. Definitely come to my college and meet me. Okay, but for that you have to study hard. Okay, Ajay. So study hard and I'm pretty sure you will be able to make it. Okay, so please enroll for this batch. Okay, enroll for this batch. Okay, please enroll for this batch by calling us on this particular number, and also make sure that you attend the mock revision one shots. Okay, mock revision one shots. Okay, that is going to start from 26th of November. Okay, so mock revision one shots is going to start from 26th of November. So please make sure you attend that as well, right? Okay. All right. भैया चार्जेस भी लगेगा, यस। एक मिनिमम चार्जेस है बस। आई थिंक ये तो सब कोई अफोर्ड कर सकता है, राइट? एकदम मिनिमल चार्जेस है, ठीक है। इट्स नॉट लाइक दैट कोचिंग की आपको लाखों लाखों देके आपको आना पड़ेगा, ठीक है। जस्ट मिनिमम फीस है, उतना तो डिजर्व करता ही हो, राइट? जस्ट मिनिमम फीस में आप एनरोल करो एंड डेफिनेटली आपको बेनिफिट दिखेगा, ओके। एंड बाद में जब आप आईआईटी में पहुंच जाओगे देन डेफिनेटली all right, so let us come back quickly over this question, okay, and we can easily prove this particular property over here. That now, how am I going to do is that now for these three circles, the center circle can be easily written of this form, that is minus lambda i's comma 0, right? Where I is basically 1, 2, 3, right? So in the similar manner, so if this particular distance of the from the origin, if the distance from the origin to center CI's are basically given in GP, then lambda 2 square will be equal to lambda 1 into lambda 2, right? Because they are all lying on the x-axis. So this is basically a 0 comma 0. This is lambda 1 comma 0. Similarly, we'll have somewhere over here lambda 2 comma 0 and somewhere over here lambda 3 comma 0, right? So this particular distance, this distance, this distance and this distance are basically in GP. So I can write this expression over here, right? Now with that and also if I take up any point on this circle, that it would be, let us say, h comma k, Okay, let us say any point on the circle, on the second circle, be h comma k. So if I have to prove that for any point on the circle h comma k to this particular circle, then by using that length of the tangent, that is basically li, would be just given as square root of s1, right? So from this h comma k, try to find out this l distance, and then you try to check out what is the l1, l2, and l3. And if you just find it out, you will see that your l1, l2, l3, let us say, then you will see that l2 square will be also coming out equals to l1, l3. Okay, L1, L3. Okay, so by this you can prove that the length of the tangent from any point on this circle x square plus y square is equals to c squared is definitely the in GP for the this particular circle over here, right? So I hope this particular question is clear and you must have easily proved it. Okay, so this is how you can prove it, right? So please try to do it properly and then let me know whatever proof you got, right? Okay, so let us now move forward towards understanding another concept, that is regarding the normals, right? So normal to a given circle is another important concept, but for case of circle, the normals is a very easy concept, right? So normal to a circle is a very easy for case of a circles, because the normal to the circle will always pass through the center, right? So if I have a circle like this, so if I have a circle like this, and if at any point x1, y1, if I want to draw the normal, it will definitely pass to the center like this over here, and this is my normal, right? So let us call this as point P, and this PT is a tangent and this PC is the normal, right? So this PC, the normal to the circle, will always pass to the center. So it is very easy for us in case of a circle to draw the normal, right, or write the equation of the normal. Hence what we can show is that from here the equation of the normal for the circle is definitely going to be something very easy, because we already know the center. So it is y minus y1 is equals to, the slope will be y1 minus of minus f, that is going to plus f, divided by x1 plus of g, because we know center is basically minus g comma minus f. So I'm just writing the equation straight line joining 2 points, right? So this is going to be the equation of the normal. So normal equation at this point P, which is given as x1 comma y1. Okay. So this is how we can easily formulate the equation of normal. So I hope this is clear to all of you, right? So with this we can move towards solving question. Okay, so let us quickly go on towards solving some problems, and with that I think we will be done with the particular concept of this normals and tangents, right? And then we will move towards understanding another very important concept, that is the concept of the chord of contact. भैया सॉरी फॉर द डिस्टरबेंस, बट ये यहाँ पे सब शुरू से पढ़ाएंगे, क्योंकि मेरे को कुछ भी नहीं आता है और कोई एक भी टीचर मेरे को पर्सनली मेंटर करेगा। देखो ये जो तुम्हारे पास जो ऑनलाइन बैच का एक्सेस मिलेगा ना तुम्हें, अजय, दिस पर्टिकुलर बैच इज बेसिकली फॉर वन ऑन वन ट्यूशन, ओके। यहाँ पे जो मेंटर रहेगा, जैसे मैं रहूंगा तुम्हारे साथ मेंटर, अगर दिस एंड व्हाट आई विल डू इज दैट मैं तुम्हें एंड टू एंड गाइड करूंगा, ठीक है। ऐसा नहीं कि मैं तुम्हें कहीं पे भी ऐसे एज्यूम करके चलूंगा कि तुम्हें ये आता है, तुम्हें ये नहीं आता है, राइट। तो मैं यही एज्यूम करके चलूंगा कि तुम्हें ये पर्टिकुलर चीज नहीं आता है, एंड विद दैट पर्टिकुलर बेस मैं वहां से तुम्हें आईआईटी का तक छोड़ के आऊंगा, राइट। दैट इज व्हाट माई कमिटमेंट इज, ओके। सो आप एक बार डेमो क्लास के लिए एनरोल करो, ठीक है, एंड डेफिनेटली आप उसके बाद आपको पता चल जाएगा कि कैसे हमें वहाँ पे पढ़ाया जाता है, राइट। सो वो बेसिकली एक ऑनलाइन प्लेटफॉर्म, जहाँ ऑनलाइन वन ऑन वन क्लास है, जहाँ पे सिर्फ मैं और आपके साथ इंटरेक्ट करेंगे। वो काफ़ी इंटरेक्टिव क्लास भी होगा, जहाँ पे मैं आपको डाउट्स पूछूंगा, डायरेक्ट आपको डाउट पूछूंगा और पूछूंगा कि आपको समझ में आया कि नहीं आया। एंड डेफिनेटली मैं वहाँ पे आपको असाइनमेंट्स दूंगा जो पर्सनली आपके लेवल पे होगा, राइट। वो ऐसा नहीं कि कोई भी स्टूडेंट सबको आता ही है, मैं एज्यूम करके नहीं असाइनमेंट दूंगा। मैं बेसिकली ईजी से असाइनमेंट दूंगा, स्टार्टिंग करूंगा ताकि तुम्हें समझ में आए, फिर ऐसे करते करते आगे हम बढ़ेंगे, ठीक है। सो दैट इज व्हाट इज द बेस्ट पार्ट ऑफ दिस पर्टिकुलर क्लासेस। सो try to enroll for it. Maybe you can try with the demo class today, okay, and then you can move forward with the online batch over it, okay. Okay, so let us now move towards, maybe I will give you some problems and then we can end with this discussion over here, right. So let us, so this would be some homework problems that you can try to solve in order to prepare for your upcoming examination, okay. So this would be some of the homework problems, okay. So try to solve these homework problems, okay. These six problems are there. Try to solve these homework problems and do let me know whatever answer you're getting in the comment section of this particular video, okay. And maybe with that we can proceed with understanding of the next topic, that is going to be the chord of contact, right. So chord of contact, and with that we are going to enter into the another general properties of circle, or how to find out the equation of the chord of contact, how to know the intersection of two circles, and how to find out the angle between two circles, right. So all those concepts we are going to do in the upcoming lecture. So please, if you're into this particular platform, please like, share and subscribe these videos, okay. Subscribe to the channel and also hit the bell icon so that whenever we are live you get a opportunity to contact with me, and you can get the and get your doubts clear as well, right. So with this, thank you and I wish you all the best.